we're going to try to understand this. Impulse is equal to J. J is the symbol, dimensional symbol for impulse. And J is delta P, which is F delta T, which is Newton second, which is kilogram meter per second, which is mass Vf squared minus mvi, vi on Vf squared, mvf minus mvi equal to momentum before minus momentum initial. Remind you, the momentum is mv, right? This is what we're going to try to understand. All right, so let's give you the first problem. So let's say problem number 1. So let's say there is a field, there is a soccer ball, there is a man trying to kick the soccer ball. We want to find two things. We want to find the impulse, right? We want to find this thing. We want to find this thing, this thing. How much? What would be the impulse? This is what we're going to find, okay? And then we're going to find the F, right? The force that the person exerts on the ball. That's what we're going to find. Okay, good. What did I give you? I give you location A, location B. So I gave you velocity, right? Velocity is, I don't need to mention that. So the football was at rest. So velocity initially is 0. Velocity final is 30. The time, the impact time, right? Impact time is 8 milliseconds. And that is what? 0.008 second, right? So what is initial momentum? So initial momentum is mvi. So initial momentum is 0. Final momentum, let's say the football is 0.4 kilogram. So final momentum would be 0.4 times velocity is 30. So 12 Newton second, right? Okay, good. So what is then the impulse? Impulse, which is J, which is, okay. So what is impulse? Impulse is delta P is equal to P final minus P initial. So what is delta, or what is P final? P final is 12 Newton second. P initial is 0. So what is it? 12 Newton second. So impulse in J is delta P is equal to F delta T is equal to, everything is equal to what? 12 Newton second. Okay, good. We are find the F. To find the F, which equation we're going to use? Let's highlight it. Let's highlight the equation we're going to use. We're going to use this one. This one, and we're probably going to use this one. Right? Okay, these two. Alright, let's use them. Alright, F delta T is equal to momentum final minus momentum initial. Right? So F is equal to delta P over delta T. What is delta P? I think we have delta P here. Delta T, I think we have delta T somewhere. Right? So it's 1500 Newton. Okay, let's consider another problem. Problem number 2. Alright, let's see what we can do to improve our understanding. Let's consider Tom Cruise. Tom Cruise, which is 70 kilogram probably, maybe 80 kilogram. Okay, 80 kilogram. So Tom Cruise jumped from 45 meters above the ground. So he is here now. So this 45 meters. I want to find the time. Alright, impact time. So impact time, to find the time, you can find time many ways. One of the ways D is equal to VIT plus half AT square, right? So this is 0, this is negative 45, this is half negative 10 t square. So time is 3 seconds. All right. Velocity. Velocity you can find several ways. Velocity is 2gh, gh. So 2 times 10 times 45, which is 30. Or you can find the velocity is this way, vi plus at. This is 0, a is 10, 3. So both ways you get the 30%. Okay. Initial momentum. Initial momentum is 0. Final momentum. Initial momentum, final momentum. Okay. So change in momentum. Okay. Let's see. It's change in momentum. Change in momentum is how much? M delta V, right? So M is how much? 80. Delta V is how much? 30. So change in momentum is 2400 watt Newton second. Good. Now we're gonna have him fall from 45 meters above the ground, right? He's gonna jump on the water and he's gonna jump on concrete. He is here. All right. Okay. So in this case, what is the impulse? 2400. What is it? Newton second. What is the impulse? 2400 second. Concrete, how long does it take? It takes 1 millisecond. Water impact time is 50 milliseconds, right? So this one would be 50 times as bad, right? This one would be 50 times as bad. Take a look, the jumping. Okay. This one would be 50 times as bad. Okay, let's see whether that's true. All right. Force is Newton second law. Delta P is 2400 and T is 0.05 second. This is 0.05 second. So F is equal to how much? 240000 divided by 5. 5 goes to 24 times 8. 48,000 for water landing. 48,000 Newton. This is going to be 5 times more. This one going to be 5 times more. 50 times more. This one going to be 50 times more. Let's see whether that is true. So F is delta P over delta T. Delta P is 2400 and delta T is 0.001 second. 0.001 second. So F is equal to 24001230 Newton. Alright, so this is 50 times as bad as this one. So who is landing would be safer? Of course, landing on the water would be much safer than landing on the what happened? Concrete. Now we're going to change the approach. Tiffany landing would be 50 times worse. How many times? 50 times. Let's see why. Okay, let's use Tom Cruise as an example, because the guy likes to jump. You put him on the rooftop of anything, he will jump. Okay. You're jumping from 3 meters above the ground. Right. Tom Cruise jumped from 3 meters above the ground. Okay, good. Few things I want to remind you. right? This is gonna be the Bentley and this is gonna be Strictly. So this one has to be Bentley. The impact time is bigger, 50 centimeters. The Strictly impact time is smaller, but if I put that small, then I cannot write that. So let's put it like this: 1 centimeter, which is 0.0001 meter. Okay, so you have 50 centimeter or 0.5 meter, and you have 0.01 meter, right? Okay, great. Let's find the velocity. What is the velocity of it? To find the velocity, from here to here is velocity is 2gh. So velocity is 2 times 10 times h. So velocity is 60. So velocity is 60 is 49 is 7, and 64 is 8. So this is probably 7.7 meter per second. What type of velocity is this one? Velocity initial, right? This is the impact time, right? Okay. If you look at the video, you're going to see that he is touching the ground with 7.7. And how long it takes for his body to come to rest? 1 centimeter. So 1 centimeter, right? His body oscillates 1 centimeter only. So velocity final 0 meter per second. Our goal is to find t, right? How long his body oscillates. We cannot say 0 time, right? We cannot say 0 time, but we definitely can say it's very close to 0, right? We're gonna find it. Let's find the velocity average. VR plus VI over 2. So what is it? 7.7 plus 0 divided by 2, 3.9 meter per second. Let's find the momentum initial. 7.7 times E is 70 kilogram. 7.7 times 70, 540 Newton second. P final will be 0 Newton second. So what is impulse? Impulse is negative 540. Okay. Now I think we can find the time. Time is not 0, very small. Time is distance over velocity. Distance is 0.01. 0.01. And velocity is 3.9. So the time it takes 0.0026 seconds. Now we are ready to find the force. So the force over here should be what? The force would be delta P Newton second law delta T. So the force is delta P is 540. Delta T is of course negative. Delta T is how much? 0.0026. So the force is 21000. Newton. What is the initial velocity? Initial velocity is 7.7 meter per second. Final velocity is 0. Initial momentum is 540 Newton second. Final momentum is 0. Total momentum is negative 540 Newton second. Average velocity is 3.9 meter per second. time is distance, which is 0.5, upper velocity 3.9. So time is 0.128 seconds. Alright, so we are trying to find the force, right? Force is delta P over delta T. So that is 540 divided by 0.128. And that's going to give you F is equal to 4200 Newton. Box it. Alright. So this one is 50 times as bad as this one. Alright? And that's what we wanted to show, right? The steep knee landing is 50 times as bad. Bent knee landing is much safer than steep knee landing. That is the reason. Alright, next. Maybe I'll give you one more problem to help you understand the impulse. So pay attention. One more problem. Let's give you a graph. FT graph, right? F is in Newton. T is in microsecond, millisecond, let's say. I'll give you a graph like a trapezoid. I'll give you the time 2, I'll give you the time 6, I'll give you time 10. I'll give you the force. What I want you to know, there is an object, which is probably ball. The mass of the ball is, let's say, 0.07 kilogram. I want you to find the velocity of the ball, final velocity of the ball, after you apply this impulse on the ball. What would be the final velocity? Alright, let's find it. Impulse is equal to BH or half BH, BH or half BH, depending on the scenario, or F delta T or delta P, or half MV final minus MV initial, or P final minus P initial, or Newton second, or what? And that's it. I think that's enough. I see a triangle. So I'm going to write half BH. I see a rectangle. So I write BH. I see a triangle again. So I write half BH again. Okay. So now I'm going to do the math. Half, before you do anything, convert it to second. 0.002, 0.006, 0.01. So the base is 0.002, height is 20, plus base is 0.004, height is 20, base is 0.004, height is 20. Okay. 2 goes to 20 10 times. There is a half because this is half. So half is missing. 2 goes to 20 10 times. So 10 times 0.002, 0.02 plus 0.004 times 20 is 0.08 plus 0.04. So this is 0.14. What is it? 0.14 what? 0.14 Newton second. Equal to what? Equal to this one, right? What is initial velocity? Initial velocity is 0. We want to know final velocity. So then final velocity must be what? I want to do it here. I want to do it here. So final velocity is 0.14 divided by mass, and mass is how much? So final velocity is 2 meters per second. I'm going to do the last problem. Problem 5. Last problem should be very easy. Ft. So let's say this is negative 20, this is positive 20, this is 2, and this is 4. What is impulse? Or delta V? Okay, let's see. What is impulse here? 20 times 2 is 40 meters a second. What is impulse here? Negative 20 times 2, negative 40 meters a second. Alright, so what is change in momentum? 0. I'll see you tomorrow. Tomorrow is the exam 8. I put all the resources on the website.